Okay, this video is going to cover what are called, decimal times decimal, but these are going to be known as greater than a whole. And so when you look at this problem, both of your numbers here have decimals involved. So it's 1 3/10 times 5/10. But when you solve this problem, there's going to be a good chance when you solve it that you're going to need 2 hundredths models to solve it. And so it's a little bit different than the other ones, but as long as you pay attention and you follow along with this and take good notes, I don't think these are going to be just too tricky. There's one part that usually gets kids on this, and we're going to talk about it because it's usually a pretty common mistake. So on this problem, this is going to be 1 3/10 times 5/10, and so this time I'm going to take, a color here, and I'm going to think again from my previous video over these. You still have to think about up and down and left and right. And so I'm going to take 1 3/10 here, and I'm going to think, okay, that's going to be my up and down. I'm going to shade that going up and down. And so what's unique about this one is you have a whole. You have 1 3/10. So technically, if I'm going to shade this, really this whole first hundredths grid gets shaded because it's representing one whole. And so I'm going to do, again, just a quick shade on this. And so now I'm going to get all the way to the end here, and I have my one whole shaded. But then I have to keep going because my problem's not 1 times 5/10, it's 1 3/10 times 5/10. So I would need 3 more on this second grid. Now I can stop shading after I get 3 more. So if I stop here and I just think about what I did, I've modeled 1 3/10 going up and down. The next part, switching colors here, I'm going to get blue for this. I'm going to think about my 5/10 going left to right. And then now I'm going to kind of stop and think, okay, well, my 5/10, it's got to go left to right. What has to happen here, this is the misconception. So this is the part where kids make errors on, they make mistakes. If there's a test question over this, this is usually one that gets kind of tricky. So watch this. So I have to think if it's 5/10, if I'm timesing it by 5/10 in this model, when I start shading my 5/10, I have to shade 5/10 all the way across. I can't just stop it at the end of the first hole. I have to shade it all the way across. So it's going to look weird, but basically what I'm creating is I'm creating some overlap in 2 places. And so we're going to really see it at the end kind of come together. So let me get my 5/10 here. I've almost got it. All right. So now let's switch back over to a black color so we can really analyze this thing and see what I see. Okay, I tell you what. I think what I want to do now is I want to show the algorithm. I actually want to show this problem out to the side and show what we should get as an answer. So really on this algorithm, it's going to be 13 times 5. If we say forget the decimals, just straight multiplication, 13 times 5, let's see what we get. So 5 times 3 is 15. 5 times 1 is 5, plus an extra 1 is 6. But with my 2 jumps that I have to make in my answer, I'm going to have an answer of 65 hundredths. So it's kind of like this. If I look here, I've got to see 65 hundredths in this model somewhere. All right, on this problem, I'm going to go and I'm going to circle my overlap in 2 places. So I'm going to circle it here, and then I'm also going to circle it here because it really occurred twice. There's overlap in 2 spots. So my first problem, my first grid over here on the left, when I look at it, it looks like I have an area of 5 and by 10 basically. So if I counted, that's 1, 2, 3, 4, 5. And then going across, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I do the math there and I think, okay, how many are here without having to count them all, it's basically 5 times 10, which is 50. So there's 50 hundredths overlapped over here. On this side, I have a group of 1, 2, 3, 4, 5 going up and down, and then 1, 2, 3. And so if I do the math there, 3 times 5 is 15 without having to count them all. There's 15 hundredths that are overlapped. But if I combine them and I see that the two groups together come back together, all of it overlapped together is 50 hundredths plus 15 hundredths, which then I can connect to my answer. Now that's going to be 65 hundredths. And so it's a little bit different looking. They're unique. They really are. These are kind of, unique problems. And I always tell my students, when tests are made, they're going to go and look for the ones that are unique and are going to trick students, because that's their job when they make a test. They want to try to trick you. And so these are ones that I always tell my students watch out for, because it's very likely that they're going to throw one of these at you. And so you just have to go real slow and really think about it. The common mistake, the misconception is this part, and I'm going to try to really make it stand out. This part right here will get left off, and kids won't count that. And so like a popular answer here could be 50 hundredths. They just count this first section. Well, you got to understand, if it's overlapping it in multiple places, that counts too. So you got to be really careful on these. Okay, for this one, I'm going to just come up with my own problem here. I'm going to write the problem of 1 2/10 times 4/10. Okay. And so I'm actually going to start this one with just an algorithm. I just want to see what's going to happen here. So I'm going to write it as 1 2/10 times 4/10, which means it's just going to be 12 times 4, basically. And you should know your 12s in 5th grade, so 48 should come to mind. Well, we can work it. 4 times 2 is 8. 4 times 1 is 4, so it was 48. I'm going to make my jumps here with my decimal, and so it's kind of like, all right, right off the beginning or right off the bat, I should see 48 hundredths as an answer at the end of this thing. All right, let's think about modeling this one. So we've got, I'm going to choose a couple of different colors here. All right, so I'm going to pick green for my 1 2/10. Let me get my colors figured out here. All right, so I've got 1 2/10. I'm going to shade that going up and down. And so I'm going to start with one hole again. And so I'm going to go a little bit quicker this time. Again, not the prettiest shading, but it works. Okay, and then I'm going to complete it on the other side. So 1 2/10 means I'd have to shade 2 more of those columns. Now I'm going to switch over. Let me get red. So red's going to be my other color or my other number, which in this case it's 4/10. And I'm going to shade it right to left, not up to down or up and down. Now again, here's probably the biggest issue. When I'm shading, I have to continue it on the other side. So there's 1 going across. Here's going to be 2. Here's 3. And then here's 4. And then now, let me go back to my black color. And let me get everything circled that is overlapping each other. So I'm going to kind of do this one as a group together. Right here at this bottom corner, this bottom left-hand corner of the model, I see that there is definitely some red and green overlapping. And so let's see if we can't put it together and see if it makes sense. So without having to count all of them, follow me on this and it'll make sense. A lot of times you're kind of thinking about an area problem. So you're doing 1, 2, 3, 4 going up and down. That's got overlapped over here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 4 means there's an area of 40 hundredths that has just gotten overlapped. On the other side, there's a 1, 2 by 1, 2, 3, 4. There's a 2 by 4 or 2 times 4 area. So basically there's 8 there. There's only 8 hundredths that are being overlapped. And so now if I combine those two together, I get that answer that I got with my algorithm of 48 hundredths. And so again, on these, just really watch yourself, be careful. Really watch for that one part that extends to that second whole number, because that's usually the trickiest part. You have to extend it on. And again, it's that one part. These are unique. So when they're unique, those are going to be the ones that maybe they're going to pick to test you on. And they're going to test your knowledge on that. So you have to be ready for that. You can't let them trick you like that. So really watch for that. And again, think about that overlap, those overlapping areas where you see those two numbers, coming together and giving you your answer.